All right, here we go. So graphing sine, you can either memorize this or you can think about graphing just the axes on the coordinate circle. You've got the 1, 0, the 0, 1, -1, 0, and 0, -1. Sine is the second coordinate. Remember, computer science. And so these are the coordinates that are going to help us. So here we've got 0, or 2 pi. And in both of these cases, we have sine is 0. So at 0 and 2 pi, we have sine is 0. Then at pi over 2, we have that sine is 1. So that will be right here. At pi, right here is pi. We have sine of 0 is, we have sine of pi is 0. And then here's our 3 pi over 2. So a sine of 3 pi over 2 is right here is -1. We can go ahead and graph that. Make sure you curve it and don't make it a V. Put arrows on it because sine does continue past what we have graphed right there. All right, graphing cosine, we can use the same exact table here, or chart. And this time, however, we're going to look at what? We're going to look at the first coordinate because cosine is the first coordinate. So here is 0, 0. All right, so cosine of 0 and 2 pi are both 1. And then we have cosine of pi over 2 right here is 0. Now we're next to -1. And then we've got 3 pi over 2 right here. Cosine of 3 pi over 2 is 0. Again, make sure you don't make this a V. You just curve that just like this. Arrows, please, because the functions continue. All right, tangent. Tangent is sine over cosine. So going back here, we realize that we can just divide the two values. All right, so here, I'm going to do 0 divided by 1. So that gives me here, I've got a tangent of 0. Right here at pi over 2, when I do 1 divided by 0, I get undefined. Next, I have 0 divided by -1. That is going to be 0. And then at 3 pi over 2, I'm going to have -1 divided by 0, which is also undefined. Let's go ahead and let's graph the 0 and the 2 pi and the pi at 0. Okay, there's my 0, my pi, and my 2 pi at 0. And then let's go ahead and draw an asymptote at pi over 2 and 3 pi over 2. And you can see the pattern already, so we can go ahead and continue that. I'm going to continue it on this side as well. And then the next thing we're going to do is we're going to go ahead and graph what happens in between these. And you can either memorize this or plug in a pi over 4 if you'd like. But I have this memorized that it looks just like this. Make sure you're not touching those axes, but you are making it look like it's approaching that axis. All right, that's it for tangent of x. Next up, we're going to find the area of each sector. Well, to do this, we have to use our sector formula, which is 1/2 r squared theta. Plugging into that, I get a equals 1/2 5 pi, oops, excuse me, I got to put in my radius first, 11 squared, and then 5 pi over 4. Well, of course, 11 squared is 121. Okay, so I'm going to have 121 divided by 2 times 5 pi over 4. Well, we need to reduce that. So first I multiply 121 times 5, and that gives me 605 pi over 8. Well, let's go ahead and use our math frac feature. So I'm going to do 605 divided by 8, then press math fraction, and I realize that that is completely reduced. We can't do anything more with that, so that's simply our answer. All right, moving on to the next one. Again, we have area equals 1/2 r squared theta. So I'm going to have 1/2 my radius being 17 squared, and then my theta 19 pi over 12. Okay, 17 squared, I can't do that one in my head. That gives me 289, so I'm left with 289 over 2 times 19 pi over 12. Okay, multiplying 289 times 19, I get 5491 all over 24. And don't forget about your pi here. Now I'm going to take that number and I'm going to divide by 24 in my calculator, and I'm going to ignore the pi. I'm going to math frac it, math then fraction, and I get a reduced fraction that is exactly that. So that's our final answer. All right, next question here. Find the angle. So we're solving backwards. We're given the area and we are also given the radius. So here I'm going to use this formula, but I'm going to plug right in right away. So I know that we have 25 pi divided by 2 is equal to 1/2 10 squared theta. Okay, let's reduce that. 1/2 10 squared theta, well, 10 squared is what? It's 100, and 100 divided by 2 is 50. Okay, so this whole entire thing right here becomes 50. So I'm left with 25 pi over 2 equals 50 theta. Okay, next thing I'm going to do is I'm going to divide by 50, or you can think about it if you want as multiplying by 1/50th. So be multiplying by 1/50th right here. And these are going to cancel. And I'm left with theta is equal to 25 pi. And then I do 50 times 2 right here, which is 100. Okay, well, what does 25 over 100 reduce to? It's definitely 1/4, so that's going to be theta equals pi over 4. And we're done there. Okay, same process for this next one. I'm going to have 4 pi over 3 is my area is equal to 1/2 my radius squared, which is 4 squared theta. Okay, well, I know that this right here is 1/2 of 16, which is 8. So I'm left with 4 pi over 3 equals 8 theta. I'm going to multiply by 1/8 on both sides. My 8 and my 1/8 cancel. And I'm left with 4 pi, and 8 times 3 is 24. Okay, and that's going to give me, because my 8 and my 1/8 cancel, that's going to leave me, sorry about that, folks. That's going to leave me with just theta. And 4 over 24, that reduces to a 6, so the theta is equal to pi over 6. If you wanted to, you could throw that into your calculator at this right here as well and do math frac with it. All right, here we go, defining cosecant x, secant x, and cotangent x. Well, remember, cosecant is the reciprocal of sine, sine being opposite over hypotenuse, so this one is going to be h over o. Secant is the reciprocal of cosine, cosine being adjacent over hypotenuse, so this here is going to be hypotenuse over adjacent. Cotangent is the reciprocal of tangent, tangent being opposite over adjacent, so this here is a over o. Now I'm going to kind of use that on the next problem here. I'm going to remind myself that cosecant is h over o, cotangent is ao, and secant is h over a. With my angle G here, let's go ahead and label our sides. Circling G right here, I've got my opposite. Across from my 90 is my hypotenuse, and then I have my adjacent. So cosecant of G is going to be 5, my hypotenuse, over my opposite, which is 4. All right, next thing we have to do is angle D right here. So I need to erase everything I have here and relabel my sides. So I'm going to circle my angle D. Across from that is my opposite. Across from my 90 is still my hypotenuse. And then the remaining side is my adjacent. So cotangent of D is going to be my A, which is 4, over my opposite, which is 3. Secant D is going to be hypotenuse of 5 over my adjacent of 4. All right, last couple problems here. What is the cosine of x if sine of x is equal to 6 over 11? Note we are in the first quadrant. So I'm going to go ahead and graph that. I know I've got my reference angle right here. I know sine of my angle x is opposite over hypotenuse. So I'm going to put my 6 here and my 11 here. Well, cosine is adjacent over hypotenuse, so I'm going to solve for this side right here. And to do that, I've got my question mark squared, or x squared, plus 6 squared equals 11 squared. That gives me x squared plus 36 equals 121. Doing 121 minus 36, that's going to give me 85. So I have x squared equals the square root of 85. I don't think that's reducible, so I'm going to go ahead and just write this right here as the square root of 85. All right, now cosine of x is going to be adjacent over hypotenuse. My adjacent is now the square root of 85, and my hypotenuse is 11. We should check at the very end that the sign is correct for our answer. And we know that all students take calculus. In this case, all sine, cosine, and tan, all of them are positive. Our answer is positive, so we are happy. Okay, next one is in our third quadrant. So what do I have here? I've got something like this. Well, I've got my opposite over my adjacent. So my opposite is going to be 8, right? Because here I've got opposite over adjacent. So my opposite is 8, my adjacent is 3. However, let's think about the sign here. Here we are going left, and here we are going down. And that's okay, right? Because here it says positive, and we know that a negative 8 divided by a negative 3 is a positive. But we still need to solve for our hypotenuse here because we're being asked for sine. So I'm going to do negative 8 squared plus negative 3 squared equals x squared. That gives me a 64 plus a 9 equals x squared. That's a 73 equals x squared. Square root both sides, and I'm left with square root of 73 equals x. All right, so I'm going to erase this question mark here, and I'm going to put the square root of 73. And now I know that my sine of my angle theta is equal to opposite over hypotenuse. In this case, negative 8 over the square root of 73. Now let's just make sure this is the correct sign. All students take calculus. The only thing that should be positive here is tangent, which is true from the start of our problem. So we definitely have the right answer in terms of positive and negative, but I actually want to take some time right now and rationalize this. So sine of theta equals negative 8 over square root of 73. Let's go ahead and rationalize that. What are we going to multiply by here? You're right, it is the square root of 73 over the square root of 73. So this is going to be sine theta equals negative 8 square root of 73 all over 73. Now I don't think 8 and 73 are reducible And check real quick. Nope, they are not. So that's our final answer right there. Explain how you're feeling about online teaching. I think I miss you a whole lot, and I hope you guys are doing great. I hope that this is being a productive way of using your time, and I hope you are learning the material. Please reach out at any time, and good luck on your test. Thanks.